I'm going to start a new course on the MongoDB. So this is my second lecture, which I'm going to talk about DB introduction to NoSQL and polyglot persistence. So this is basically consists of three things. First one is what is the relational databases and relational why we use relational databases, and next one is problem with the relational database. And next part we are going to talk about NoSQL databases, and this will cover about common characteristic of NoSQL databases. And after the next step, the third part I'm going to cover is type of NoSQL databases, and this cover like data models, type of NoSQL databases, key value storage, column storage, and so graph documented. So let's talk about the first part about the NoSQL. What is the problem? What is the problem of relational? Sorry, what is the problem of relational database? So let's talk about this. So today we are facing. Yeah, let me make the bigger so that you guys can see. Today we are facing the rapid expansion of data-driven businesses, especially the businesses that are web-based and have the enormous amount of data is being transferred every second. In fact, almost 90% of data on the web has been created in the last several years. Usually, data has to be stored in database. However, since every business is different and different need to be taken into account when the looking way of store the data, there are two routes which we can take. First one, we can store data into relational databases, relational which we call RDBMS, and NoSQL is I'm going to talk about the next. So further on, you will cover all the strength and weakness of both, but it will be largely focused on the NoSQL database, why we need to consider to them as a solution to our problem. So let's talk about relational databases and what's the problem they have. The concept of relational database and concept was the first proposed in 1970 by F. Code. It has been ruling out of world since the mid 1980s. Somewhere in the 90s, the concept like object database threatened to take in regain, but that's never happened. There are many reasons why the people love relational database and why they have to be dominated in such long time. Why relational databases? Firstly, they are very close to way we see the world. Okay, so all the data, what we see, this is like it's the same the world is looking like. So entity is the application domain or model, and naturally using the record and table. The relationship between these tables are created based on relation that exists between the corresponding entity in the application domain. So this based on like employee and department, if you talk about, so we create employee table, we create a department table, and then how they interact with each other. So based on that we create. So it's a purely like business oriented. What is the business? So they represent business things. Second part is relational database is also very strong consistency, meaning the once change made in some of the record, it can be seen in every application in the domain. So it's very consistent. Once you change, it will either is the rollback or either it change. So which will reflect all the business. This made relational database is ideal integration mechanism with the multiple applications sharing the common database and data. Third part is the relational database has a transaction feature. This gives us way to assign to change the multiple tables and roll back the previous changes in case of the instruction or transaction got failed. This is a fairly complex but powerful feature is used in data-intensive system provided by stability. Also the next part is they have the feature of join in the SQL. SQL has a pretty much become a standard language, a wide range of relational databases, and since it's very expressive and easy to learn, this made more accessible to relational database. Hence the SQL provides expressive of the developer. To sum up, so basically, to sum up all these things, why the relational data is very popular. So consistency, as I talk, integration, expressiveness, stability is the reason we can find the relational databases within that nearly every business of solution. So this is mainly the core. So this is the relational database. It says consistency, integration, stability, and expressiveness. Now let's talk about the problem of relational database. So world has been changed in last 5 years or like few years. Already mentioned, it is where the large amount of data is stored, transferred, and manipulated, to most of which the unstructured. So previously, as we talk about the entity and relations, so all the data in row and column format now is unstructured, means they don't have fixed format. Today is coming 5 columns, and tomorrow is coming some text or something. This does not necessarily mean that data is a lack of structure, but that structure is, especially in the tabular format, is hard to grasp and define. What I mean is here, so these data is coming data, it's very difficult to convert into tabular format. For example, an application is using unstructured data would be customer analytics, where the companies is use collect data to analyze to improve the customer relationship management. We don't have we don't have as many standalone applications today for which a relational database were made. However, these applications have changed within the introduction of the social media, internet on the things, microservices. This advanced world describe the system and lot of data has given to space of NoSQL database to blossom. The biggest problem the relational database is today is the impedance mismatch. So this impedance mismatch is what I mean is here. In term is used in general describe the difference between relational models in memory data structure. Relational in memory data. So for example, so this is very important impedance mismatch. For example, object in the application memory is often saved form of graph, right? Object is this is your front end, and this is applications is using and mapping, and this is a relational database, and which is checking from 3 tables. Which different form of tabular format and data is saved in relational database. This is why you always need to modify to cut that. So if you want to modify this table, now it's somewhere in the memory database. So if you want to change something, then you need to cut this connection. When you cut this connection, that means user would not be able to see the data. So there, it's somewhere we need to do the code changes or code free. So arrange the data before we save the relational database. So this is such a big problem, right? Since this modification are coupled with the modification in the application itself, as it takes long time to extend and maintain these databases. Today, application and system have demand for 20/7 availability, which means there is no longer time to run the system off on the weekend or updates database. Application user is also demand to rapid response time, so the front end can't afford to slow down while the database is updating itself. So the first issue is this impedance mismatch. So the second, another issue with relational database is they are not in the cluster oriented, right? When you are trying to have the replicator, right, will have to replicate it in all the nodes. Since all of them need to be the consistent before the transaction is allowed to commit, this makes the write expensive operation, and in the relational database, replicate affect the performance significantly. Since you don't want to sacrifice consistency, you must wait for all the replica to become consistent before you can read the database. So ability to manage data dynamically, to go production quickly, and develop software using the agile methodology, all that require more flexibility than relational database. So these are the 2 problems which we're talking. So now that you know all about the problem in relational databases, we will learn about the NoSQL database and they are used in overcome the problem. So this is the NoSQL data. The term NoSQL oriented as a Twitter hashtag for Meetup back in 2009, and it's sometimes translated as acronym not only SQL or shorthand for NoSQL. This term is pretty loose, and it's used to cover a wide range of databases that try to tackle problem relational databases have a newer application. So this includes, it has a flexibility, it has a scalability very fast, it has a good performance. Nevertheless, in order to do these databases have sacrificed some of these good things that relational databases is provided, like SQL and all those we cannot use. First one is expressive query language. Second index we will miss. Transaction mechanism also we will miss. Strong consistency we don't have in NoSQL. Here is some example of NoSQL databases: Cassandra, HBase, and CouchDB, MongoDB, Hypertable, Neo4j, Redis. So common NoSQL characteristic. So let's understand about characteristic of NoSQL. NoSQL database have these common characteristics. They usually don't use the SQL. However, they have their own query language which is often similar to SQL. For example, Cassandra querying language called SQL, or Hodge, it's called NoSQL, and usually extend SQL processor. They are not relational databases, meaning they don't provide set of formally described tables which data should fit. Especially relational database name as they because they are structured around the table and relation between two tables. Those tables. NoSQL database does not have table, or at least not have the way the relational database do. Therefore, no relation. Most of them are cluster friendly. The initial idea was to store data as a multiple machine, but some of the SQL databases are graph-oriented, just like many applications today, online social network where the people are nodes and connected to other nodes is a edge in the friendship relationship. They don't enforce fixed schema as strongly as relational database do, hence it's possible to add a field in the record without the first making the change of structure itself. Since it's the relational database, you have to know the advance what you want to store. NoSQL databases make the process easier. All of above are common characteristics, but certainly by the no means are their definition. Uh, NoSQL is a point. I don't think we will have a full proper definition of NoSQL database. However, this is made for we best goes to hands in the SQL free splits identity. Now, now we are familiar with the NoSQL. It will be learned out a different types. So we have few basically three things which solve the problem as flexibility, scalability, and performance. So let's talk about now the type of NoSQL databases. So these things we are going to talk about like database model, type of NoSQL, key value, column oriented, column versus relational databases, then graph storage, document storage, multimodal. So these are NoSQL. It can be key value. NoSQL when can columnar database, can document database, can graph database, can multimodal. So as previously mentioned, NoSQL database have shifted to separate themselves from relational database as they are no longer to part of the. But what does it mean? This means they no longer to use relational data model. The NoSQL basically database model is a model through which receive the data in the database. The relational database model can be visualized as a set of tables which each row represents a different record and different entity. Type of NoSQL, as I said, key value, column, graph, and document. Key value is in fact key as if you know about Python the map. So it's similar to map. Efficiency associated with array stored in the disk. It is the single key lookup and directory dictionary. So it's big. The good thing about this database is they can read very quickly, but the database are not good for reverse lookup in additional analytics. For example, this type of database is Redis. Column storage is the subset of NoSQL database. It's kept as somewhere into tabular form. So what does it mean? It does means, well, you probably know relational database keep all their data in their tabular form, where every row represents entity. Since every row is saved separately in this, it could be the row aligned data. But when reading the kind of data, it's always read the whole the rows. Even you don't require to all the columns. That's the only value. Column store approach means column store. On the other hand, change this approach a bit. They store data in called column families. That means in column order. For example, first, ID in all record is saved. So ID will be one column family can have multiple columns. So ID, then store the names, etc. So the big deal. So this is a big deal because it's possible to get whole column in a more efficient manner than it was when you all the rows had to pull the values from each row. Basically, we can get more information from database in the single seeks, and also data can be easily compressed, and it goes without saying writing very expensive. Typically, example, these are databases Cassandra and HBase. Now talk about graph storage. Graph storage uses structured query which nodes, edge, and properties represent the stored data. They use for restoring network connection and for example social network. Graph store is a bit different from the NoSQL database since they oriented from the different problem with relational database. They have number of small record which lot of relation between them. For such an example, database is zero graph. Now, document database, one of the most popular type of NoSQL database is document store, which resolved around the concept of document. Document are self-describing structure, usually similar to each other, but they don't have the same. This is graph, this is key value, this is a columnar, this is a document. So unlike the row, the relational database, where every row has follow the same schema. A document can vary from each other, still belong to the same collection. So MongoDB and Hotch are example of document storage type. So multi-model database. Multi-model database are designed to handle the multiple data model allowing the single integration back. They are brand new in NoSQL world. There will be much more buzz around type. This is now type of. So next part we are going to learn about the polyglot persistence. So we talk about uh, problems of relational database, and then the solution of relational database, characteristic of NoSQL, and then we talk about type of NoSQL, and now we talk about polyglot persistence. So this is very important concept. So we're going to cover why choose the NoSQL, minimizing the impedance of mismatch, embracing the scale of data. So there are two main reasons we engineers choose NoSQL based on minimizing increasing a lot of spend time in memory database, saving some time NoSQL. Uh, yeah, so let's talk about this one first. So since a lot of effort is spent on minimizing in memory in database, saving the efforts improve the productivity, right? Minimizing the impedance mismatch. So when you do some changes, it should be minimized impedance. Sometimes NoSQL database has data model that is better suited for the needs of application. If they simplify the interaction of application code with database, this is where we have less code and so what I is trying to say that based on requirement, you can point to the HBase, you can point to Cassandra, different use. For example, mean stack param is to MongoDB, well, the whole stacks use the JSON object. The interaction with the application code and database is minimal. Embracing large-scale data. Today is very time-consuming to store large amount of data in the relational database. Businesses have need to capture the process of a lot of data and quickly because of NoSQL databases design run on a cluster, which means a better for the problem. Large-scale cluster gives the ability to store large data sets and process. So polyglot means basically what I'm trying to say is polyglot is, did I capture image? Yes, it's here. So not all the relational data model is still the best choice for the large number of problem choice. Additionally, relational databases have been here for decades, which means that there are many tools, them two people are familiar with them, unlike familiar with the concept of NoSQL database. So this is a polyglot. The difference is way they should pursue the relational database. They are no longer two only option for storage. Now we need to understand the data different situation, a multi-flow. Polyglot this is the way of looking of data store. We will lead the solution in the multiple database. Each will be different purpose. For example, SQL for financial use, part of application, MongoDB use for podcast scheduling, Cassandra use for large scale analytics. So Polyglot is persistent, has opened new door to application development. Never before have been the many option to possibility. It's also raised a lot of questions, and one of them is being which database should be used for what situation. This is approach create a lot of complexity too, since there are not simple mechanisms to maintaining data consistency. Maybe multi-model database fulfill the gap. Either way, it has not been the exciting database world since the mid of 80s. It's time to alive. So what I'm trying to say, so is a polyglot is basically you can point to different of the you can point to database dependent on requirement. For example, I have given example Cassandra for large scale event, MongoDB for podcast, SQL for a part of application. So it's a kind of like this one you can do. So for you can also read on the Wikipedia. Polyglot term refer to multiple data storage technology varying data store need to process application within the same network component, such as verifying data storage need could be arise both cases, enterprise with multiple similar. So this is what the solution is world is giving. Thank you for watching. Please like and subscribe my channel.